Here's pre-calc. It's problem 4-60. It says the graph of f of x is shown at right. Below are graphs g of x and h of x, which are transformations of f of x. Write equations for g of x and h of x in terms of f of x. So, in other words, they want us to take this graph, and let's say it got, you know like a, h, and k are your parameters for moving graphs around. Like, let's say that we just moved it up by 1, we'd say f of x plus 1. Or if we moved it left, we'd say f of x plus 1, right? So that's what they want us to do. So I think the best way to do this is to first look at the graph, and I know you can see the answers here, but look at the new graph and decide what transformation do you think happened to it. Like, did it get stretched? Did it get a horizontal or a vertical shift? Did it get flipped, like over the x-axis or something? This one looks like it got flipped upside down. So I know that when you flip a graph, it becomes negative f of x. So what I'm gonna do is I'm gonna just in pencil here, I'm gonna flip my f of x and see if it matches up with that. So when I say flip, I mean like reflect over the x-axis. So this point here, it's 2 down from the x-axis, so I'm going to go 2 up. I'm just grabbing, so this piece right here would be up here. I'm just grabbing like the bending points, if that makes any sense. This point right here, the little corners, this one's at 1, so I'm going to put it at -1 and put that piece in. And here's our slanty part. And so this graph that I've just drawn in pencil, this is negative f of x, and I'm going to look at it and see if that's enough to make it match up with this one. But I see this one's got something else going on besides just being flipped. It looks like if I took the f of x and just scooted it down some, so I can give it a vertical shift. So I can see how far to scoot it down by just looking at this piece right here. It looks like it's at 2. And it needs to get down to -1. So it needs to scoot down by 1, 2, 3. So that's why they wrote it as g of x is negative f of x, that's the flip, minus 3. Okay, so the next one is, I'm just going to look at the graph of h of x and, see what I think might have happened to it. I don't think it got flipped, but it looks like it got stretched, because this part, it just goes up higher. So, not sure. In order to see what it got stretched by, I'm going to draw a little slope triangle. See if I can figure out. I want to try 2, but I'm going to give me some numbers here. So I think this part right here is 3, and this part is 6. And this one's, I'm guessing, going to be 1, 2, 3, 3. So yes, it looks like, see how like that's 6 and that's only 3? So this h of x must have got stretched. So I think what I'll do, should I just stretch this one? Oh yeah, and so this one was confusing, because when I tried stretching it, if I just leave this piece alone, I know when I stretch stuff, like I wanted to just, double this, and then I actually do, let's see, 1, 2, 3, 1, 2, I actually do get this same graph. So at first I thought it was just 2 times f of x plus h, and then I didn't understand where that 2 came from. So I looked at the homework help, and homework help explained it kind of. They said when you stretch something, you're stretching, if it's a vertical stretch, you're stretching the y coordinate. So this coordinate here is 2, 1. And so when I put a vertical stretch of 2 on it, then that just multiplies this y, because this is x and y. It's going to make this piece be at 2, comma 2. So that's right there. But this one's at 4. So that means I need to put also a shift on it. So I need to, the difference between this is at 2 and that's at 4, that difference is 2. So that's why it's 2 times x plus 1. Oh, did it get shifted left also? Oh, okay, let's see if it got shifted left. Oh, it did get oh, obviously. See how this one, see this point is at 2, and then in the new graph it's at 1. So I see exactly where that came from. And then this one's at 1, and then it got left. So these 2 points got shifted left. So that's where the x plus 1 comes from. And so this has a lot going on. And then it's also got lifted up by 2. And we just tell that by this top part. When I do just this plain old stretch, this top part only goes up to 2. But then but the h of x goes up to 4. So that means like I need to add 2 to the end of it. So that is my explanation. That one's a hard, tricky one. They got a stretch, a horizontal shift, and a vertical shift all going on in the same function.